Good afternoon, everyone. My name is Aryan Patil. Uh, I'm from Vishwakarma Institute of Technology, Pune. Our topic of our presentation is wearable smart glove for personal health tracking. My team members are Dr. Manisha Maitre, Ritiksha Pardhi, Aditya Patil, and Bhavesh Patil. Uh, Now let's see the objectives of our project. The main objective of our project was to create a health monitoring glove that will provide multiple or various facilities to its user and will promote the use of compact health monitoring systems across India. We can we have implemented various features in this glove, which are temperature and BPM readings, then transmission of emergency alert messages, and display of patients' vital signs such as I have said BPM and oxygen saturations. The components which we have used in this project are a ESP32 module, a DHT11 temperature sensor, a MAX 3102 pulse and oxygen sensor, and flex sensor. And in order to see or receive these readings, we will be using ThinkSpeak. Now, my team member Bhavesh will explain the working of the system. Over to you, Bhavesh.
Hello. Good morning, everyone. Good afternoon, everyone. My name is Bhavesh Patil, and we will be discussing about the working of the proposed glove system. Aryan, can you show the next slide, please?
Yeah, yeah, yeah.
Okay, the sensors are responsible for collecting data of the wearer's vital signs, and they are mounted on different parts of the glove, as you can see in these figures. On the back side of the wrist, there is the microcontroller ESP32 with the T-call module and GSM module, which we have included as the main microprocessor of our glove. Then the temperature sensor for temperature sensing, we have included its DHT11 temperature sensor. For the pulse measurement, we have included the MAX 30102 pulse oximeter sensor, and we have included two flex sensors as an additional accessibility feature for the user of the glove. Uh, so this is how our glove looks like. Can you go to the previous slide? So what happens is that the ESP32 has the code that processes this information in its memory. Now, the image on the side that you can see here of the code is a snippet of that code which is in the actual microcontroller. So now what the ESP does is that the ESP processes the data received from the sensors and runs the algorithm and runs the algorithm that analyzes and interprets the data to extract essential information about the wearer's health status, like in this case, the temperature and the pulse sensing. So all the required measurements of the user are sensed by these sensors, and then after sensing the information, the data is transferred to the microcontroller for the further processing. Now, the data which is collected here is in the raw form. For example, the pulse sensor, the data is in form of the IR values and only IR values. So we have to process it and convert it into a form which we can understand. So after processing, we can get the data in form which we are used to, like for example, the degree Celsius and beats per minutes. So now, what this microcontroller does is that it gathers and processes data, and it has a Wi-Fi built-in module along with Bluetooth for wireless transmission of the data. So now the collected data after the analyzing is transmitted through Wi-Fi to the cloud platform for monitoring and processing. Now the cloud platform that we chose in this case is ThinkSpeak because of its ease of access and convenience. And this data can be represented in the graphical forms. Can you go to results, please? So, sorry, block diagram show, please. So this is how our system basically works. So the system starts, the ESP gets activated, and the code is executed. Now, after executing the code, the sensors collect the data, analyze it, and then they go to the data monitoring, which is on the ThinkSpeak system and alongside the serial monitor of the Arduino IDE. Next slide, please. The images. Yes. So now, as you can see on the right figure, the glove prototype is implemented as shown here. Now, in the second figure, on the right side, we can see the serial monitor of the Arduino IDE. Now, we can see the readings collected. The readings here take some time to get consistent and accurate to the user. So now this data that is collected is sent to the ThinkSpeak cloud system for monitoring and graphical representation as seen in this figure on the left side. So the left side figures are uh, field 1, which is the temperature, field 2, which is the BPMs collected by the pulse sensor. Uh, Field 3 and 4 are the are connected to the flex sensors in the middle and index finger. So the index finger sensor is used to call the nurse after it bends at a certain angle. The nurse is called, and this blue lamp it gets ignited. Similarly, if the middle finger is bent in case of an emergency, for example, if the patient is feeling uneasy, then he just have to bend the middle finger of his hand, and then an alert is sent to the doctor, and the doctor understands that the patient is needing him. Now, what happens if, in case the patient's BP goes about the certain threshold, which in this case we have set it to 140 BPMs. So after it crosses 140 BPMs, another alert is sent directly to the doctor saying that the heart is in critical condition. So the data in graphical form, it is shown after second to second. So that was basically how our system works. Please, next slide. Aryan, take over for the
Yeah,
conclusion.
yeah. Yeah. So now let's see the conclusion of our project. So our project mainly solves the medical issues faced by bedridden elderly people or debilitated individuals. And one of the novel features of the project is the user or whoever whichever person is using it does not need any kind of special training to use our model, and the alert system in our prototype is automated. That means it is regularly taking readings, and if any abnormalities are found, the alert system will go off. With that said, I conclude our presentation. Thank you.